Welcome, YouTube. How's everybody doing? All right, so we're into part 2 already of the 2023 SHSAT Handbook Review. Let's see how far we can get on this. I want to make sure I'm live. It's not showing me live, so we're going to fly by the seat of our pants here a little bit, because I have no way of checking that. Okay, so what I'm going to do is the sample math. Part 1 was the intro, and let me try to bring that up on my side. I think that started on page 18. That's the math section. Okay, let's scroll to that. So what I'm going to do is there's about 6 or so math examples here that a lot of people skip, and they're just as vital as the ones that they give in the two sample exams that they give. My normal modus operandi is not just to answer a question, but to kind of go deeper into it. Hello, how you doing there? What's up? Let's see. I'm not going to be able to keep track of. Let me try see if my phone has you guys in here yet. I'm assuming the fact that you saw this. Okay, here we're live. Let me just make sure it's getting this track of. Okay, we're good. This way I can see the comments. All right, so I'm going to try to answer questions extensively, not just in a cursory fashion, trying to use alternatives, trying to get at the bottom of the concepts, and just giving a lot of alternatives. That's my style. I try to separate my channel from other people's things. If you want quick solutions, you could look in the handbook, although most of those are not perfect descriptions. So, all right, so we're just going to jump into these and take them for what they are. So we have sample 1. We have the sum of 2 consecutive integers is minus 15. All right, so even if we just stop there without pursuing the rest of the question, what 2 integers would even just equal to 15? There's a whole bunch, but it says consecutive. So that would seem to be 7 and 8. There's really not another choice there. Okay, but since they're minus, then the numbers are minus 7 and minus 8. Okay, and if they're consecutive, minus 8 is smaller than minus 7. So this seems to be the 2 numbers that they're really asking us about here. Okay, and it says if 1 is added to the smaller number, so minus 8 is smaller than minus 7. So if I add 1 here, I get minus 7, right? And then it says 2 is subtracted from the larger one. So minus 7 minus 2 is going to give me minus 9. And then it says, what is the product of the 2 resulting integers? Well, minus 7 is the 1 resulting integer, and minus 9, this becomes a multiplication table issue, and you get positive 63. Okay? So that would be one way to solve that. Okay? Now that we have the 2 numbers, let's just run it through the problem again. Feed it all back in and make sure it makes sense. So the gotcha on this question, if you solved it this way, there's another way to solve it, is to make sure that you did the plus 1 and the minus 2. And be sure that you have the smaller and the larger, right? Normally 7 is less than 8. However, minus 8 is less than minus 7. So that's the gotcha. So there's one gotcha here with the plus or minus, the second one here. And then the third one, just making a silly error here. This could have been a grid in. We're not sure, but even if it gave us the answers, it might give us the answer of 61, 62, 63, and 64, or something along those lines like that, right? Let me see here. trying to figure out. I got some notes here to cover certain things with you guys. That's a blank paper. Not sure what I have here. Okay. All right, that's the way to solve it, just by logic and observation. There's another way to solve it algebraically. So, and that's part of what they're giving you here. Let me change the color one more time. Let's use green. So if you notice, they use x and x plus 1. They're the two consecutive integers. So we have x, and then the next one would have to be x plus 1, right? Well, they're telling us the sum of those two numbers is minus 15. So why don't we just do that? We can get x plus 1 is equal to minus 15. And now at this point, we map the English into algebra, and let's just solve it. So that was a plus sign there. So we get 2x plus 1 is equal to minus 15. We subtract 1 from both sides. So we get 2x is equal to minus 16. Divide 2 into both sides. What we do to one side, we do to the other. So we get x is equal to minus 8. So x is minus 8. So if you have the two numbers, then this here is minus 8. That means the number here must be one more, or minus 7. So that's another way to have gotten the minus 8 and the minus 7. It's an alternate. It makes sense. So we double checked. We did it in the blue coloring here by using logic. We also now did it the other way. Okay, and that's our answer here. Okay. Anybody in the lobby have any questions about that? Please like and subscribe, share. Do good things with this, guys. Let's see. So the number 2 is a classic math question. It's a classic SAT question. It's a classic standardized test question. And it's a classic algebra question. So I like to take things one at a time and build up. So Jenny starts a game with twice as many marbles as Keiko. So I'm going to end right there. Jenny is twice Keiko. All right. So Keiko gives 5 marbles. So that's our mapping. We're going to end up with two equations. The first equation is from sentence number 1. And we're going to try to now produce the second equation. So Jenny gave 5 marbles. So whatever Jenny has, she's down 5. But that means, and we're going to have an equal sign here, Keiko, because Keiko got 5 more, Keiko's up 5. But then it says, even after that, she, meaning Jenny, still has 10 more than Keiko. So what we want to do is, if this is Jenny minus 5 and that's Keiko plus 5, then Jenny, this side, still has 10 more. So we don't add 10 to the left side. We have to add 10 to the right side. That's another gotcha a lot of students mess up. Okay, so this is a classic age problem, because normally this problem is done as like Jenny's 5 years older than Keiko, but in this case it doesn't matter if it's marbles or whatever, it's the same thing. Okay, so at this point, if we want, we can get rid of the parens, and we have Jenny minus 5 equals Keiko plus 5 plus 10, so that's Keiko plus 15. Okay, and if we want to bring that 5 over, we get Jenny is equal to Keiko plus 20. Okay, that has both of them here, and number 1 over here had both of them. So what we want to do at this point is we want to solve for either Jenny or solve for Keiko. So I could put 2k equals k plus 20 and then solve for Keiko. And let me do that. So what I'm going to do is I'm going to replace this j by equation number 1, which told us that j equals 2k. So I can put 2k equals k plus 20. And then I subtract k from both sides, and I get k is equal to 20. All right? The question didn't ask us Keiko is 8, it says, what is Jenny? Jenny's the number of marbles. But if we know that Jenny is twice Keiko from equation 1, right? If J is 2K, then that's 2 times 40, 2 times 20, and that's equal to 40. All right, so that's one way of doing it. Another way, let me change the color to be clear, we're going to do this slightly different, was at this point here, instead of, instead of doing this replacement here, so at this point here, we're going to replace not J, but we're going to replace K. Well, if we know that J is equal to 2K, then if we divide both sides by 2, then we end up with J over 2 is going to be equal to K. So in this case, we would replace, right? If we have that original step, it was J equals K plus 20. So we're going to replace K now. J is equal to J over 2 plus 20. Okay? I don't like that fraction. So what I'm going to do is multiply every term on the left-hand side and the right-hand side by 2. So in other words, I'm going to multiply this whole equation by 2. So we get 2J equals J plus 40. I subtract the J off that side. I subtract the J off of here. This becomes J is equal to 40. And that works. So now that we double checked that K was 20 and J was 40 by doing it 2 different ways, how about we feed it back into the original question? All right. So Jenny starts the game with twice as many marbles as Keiko. So Jenny starts the game with 40, and that is definitely 2 times 20. Okay. Then it says Jenny gives Keiko 5 marbles. So at this point, Jenny is 40 minus 5, and that's equal to 35. Okay. But she still has 10 more than Keiko, right? If she gave Keiko 5, right? If Keiko had 20, Keiko now has 20 plus 25. 20 plus 5, and that's equal to 25. Okay, and now if we compare this 25 against the 35, right, we get 10. And that's exactly what the problem is asking us to do. All right, so that's how we would do that. Anybody have any questions about that? Again, please like and subscribe, people. So what I'm doing is I'm going over the samples before we actually go over the formal test A and test B of the exam, because there's some good questions stuck in the middle of these. Okay, let's see, is there any other way to do this? No, that's it. Instead of multiplying, let me change the color of this slightly. Let's bring this into Fusion. I'm going to scroll this up slightly. So we had J is equal to J over 2 plus 20. That was this step here before I multiplied it by 2. I could have subtracted J over 2 from both sides. So I would get J minus J over 2, which is half J, is equal to 20, right? And J minus a half J is a half J. So we would get J over 2 is equal to 20. And then to get J by itself, I would just multiply both sides by 2. And I still would have also gotten J equals 40. I just don't like working with fractions. They can get ugly real fast, especially if something else was involved here. And that's pretty much the scenario of this question. It's pretty much strict algebra. If you're stuck, you could certainly take choice A and run it through the question, take choice B running through the question, choice 3 and D. That's error prone. That's backtracing. I don't really recommend solving problems that way, because then you're avoiding the math, really. Of course, they don't care how you solve this. So, but sometimes that's not only it will be reliable and accurate, but it could be slow you down. And remember, this exam is timed, so you guys got to be careful with stuff like that. Uh, let's see here. Let me just make sure we're okay here. All right, nobody else is asking any questions. All right, we'll go to sample number 3. Whoops, scroll too fast. Okay, so this one's interesting. So I like to look at illustrations on a math problem before I look at the words. So I see what appears to be a rectangle, and it's telling me that the length is 3x and the width is 2x. Is it going to ask me for an area? 6x squared. Is it going to ask me for perimeter? Does it want me to do something else with it? So at this point, I don't have any other information I could do anything with. So I'm going to kind of want. So I like to look at the illustration first because when I get to the words, I want to be able to confirm what I thought. And looking at the illustrations first helps you build up your understanding of the question, and then that confirmation in the words cements it into your brain. Otherwise, you're still trying to figure out things simultaneously. And at least the way my brain works, I'd rather not do that. So it says the perimeter of the rectangle is 510 centimeters. All right, so that means normally the perimeter of a rectangle is the length plus the width plus the length plus the width, or if you will, 2L plus 2W. And in our case, they're telling us that is 510. Okay, and that's the same as 2 times L plus W. And we can also do osmosis from there. And if we divide both sides of this by 2, then L plus W is equal to 510 divided by 2, which is what, 255? Okay, so that's one way to think about this. I don't know what we need over here. I'm just thinking out loud for you guys and some of the choices that you should think about and run through your head. So then it says the ratio of the length of the width, the length to the width. So the length is 3x, right? So if we do length to width, we get 3x is to 2x. The x's cancel out, and we end up with 3 to 2. So that's also confirming what we observed from the illustration in and of itself. And then it says, what are the dimensions of this rectangle? Well, there's probably a few ways to solve this. One is actually to take this 255 here. Let me just make sure I did that right. 255, yeah, 255. If this is 5 parts, right, then each part has a certain amount. So if we were to divide 5 into 255, we would get 51. So each part is 51. So that means the 2 part here must be 102. Yeah. And then the 3 part here would be 51 times 3 is 153. Okay. And it seems to me that would be our answer. So let's try to find it. So that would be F. All right. That's one way to do it. We could have also done actually once we realized that each part was 51, it should kind of leap out at you. Also, both parts at that point should add up to 255. 153 plus 102 is 255. 150, so choice E also adds up to 255, but it's not in a ratio of 3 to 2. Okay, and you should be able to tell that just by looking at it. Same for G. Is that 255? Yes, it is, but it's not in the ratio. And then the last one's also 255, but it's not in the right ratio. So even though that total, that 255 was handy, it turned out all the choices were also added up to 255. At least a quick math in my head. I may have made a mistake on one of those. I would have to double check it. All right, so the other way is just to use the perimeter formula. Again, if it's the length plus the width, plus the length plus the width, we basically have 3x plus 2x plus 3x plus 5x, 2x, which gives us the perimeter is equal to 10 times x. And we were also told that the perimeter was 510. And by the way, there's no unit conversion here. This is centimeters, and every answer choice is in centimeters. Unit conversion should be in the top of your mind for every single question. That way you avoid doing a silly error. There's categories of silly errors. Unit conversion is one of them. That's a major source of silly errors. The second major source of silly errors is forgetting to add one or subtract one. A third source of silly errors is ignoring a minus sign, whether it's during a subtraction or the distributive property, or just they tell you a fraction is like minus 3/5 and you just use 3/5. So those are some of the top three sources of so-called silly errors, completely avoidable, right? So anyway, we have 10x equals 510. So we just divide both sides by 10. And we get x is equal to 51. So there's a couple of ways to get that 51 there, right? I did it a completely different way earlier. So, and then once we get the 51, there again, it's in ratio of 3:2. So if each part is 51, we're going to get the 153 again, is to 102. All right, that's what you need to do here with this one. Let's see, is there a third way to do this? I'm not sure. I don't think so. So that's sample number 3. I think there's one or two more here. Let's see. Okay, there's one there. Okay, so again, to me, this is an illustration. So I'm just going to observe that. I see $1 is 7 logs, and $1 is also half adult. That also means that 7 logs is equal to half adult, because if 7 logs is $1 and that's $1, then both of these are equal to each other. Maybe they're going to send us that way, maybe not. I'm not sure. Let's see. So Malika has 140 logs and 16 adults. So if he has 140, if he exchanges the logs and adults for dollars, how many dollars will he receive in total? Okay, so there the fact that logs is equal to half, 7 logs is equal to half adult is not important to this problem. What is important is that we have 140 logs, and we have 16 adults. So we can take that 140 and divide it by 7 and get $20. And we can take the 16 and divide it by half, and this is not 8. This is not 8. This is 32. Right? Just to go over here. 16 divided by 0.5 is 16 divided by 1/2. So if we do keep change flip or change the sign and do the reciprocal, we get 16 times 2, right, equals 32. And then anyway, if we add these numbers up, we get 52. So B will be our answer there. You can also read here where instead of me just doing this straight up in the future here, they set up a proportion. So it's 140 logs to how many dollars versus 7 logs to $1, right? So they put the dollars at the bottom here, and that's what the first equation told us. For the second one, they just did it the same way. So it's 16 adults, which is what they have there, to we don't know how many, and it was half adult, $2, okay? Because that's what we're trying to see, because dollars, and then if you notice, they do the same thing here. All right? So they're going to divide by 0.5 on both sides here. Remember, 16 divided by 0.5 is not 8. So that's an error a lot of kids make. If you got 8 there, you're going to get 28 as your answer. So my guess is most students are going to answer that it's 28, but that's incorrect. Right? So be careful, people. Another category of silly errors that you're, so this is a category where You haven't mastered the math. If you think 16 divided by 0.5 is 8, you haven't mastered the math. And your fluidity and numeracy and no hesitation math should be at the snaps of your fingertips to be able to do something like that. By the way, I did a video, and there's also a link on my website, GregsTutoringNYC.com / SHSAT facts that ricochets you guys into a stream I have with some multiplication things you guys need to do, plus unit conversions and a whole bunch of other things like that. Let's take a 2-second sidebar into that. Let me see if I can get this to work. Yeah, there it goes. Let's see. So if you go to my main web page, scroll down to the end of the SHSAT section, you're going to see this here, which refers you to SHSAT facts. Click on that, and it's going to bring up a thing here. By the way, my unboxing video is now available through this link as well. It's the first tab that's going to show up in a second, plus the other one. I also have an errata. There are mistakes in this handbook. When we cover them, we'll see them. In any event, if you scroll down a little bit, there's a variety of different stuff. What are the math topics? What are the ELA topics? There's a reference to formulas and rules, some of the geometry stuff, some more geometry stuff. This one right here was the one I was talking about, products to know. There was a discussion there, plus some links, not only to this here, which has some multiplication you're supposed to know, but also conversions that are important. And these are not just unit conversions, even though that's the name of this, unit conversions.pdf. They also entail other conversions like fraction to decimal or radical form to simplified form or things like that, all right? So give both of those a click. You can click them and download the computer and read them at your leisure. I do have a video on the products to know one that talks about its importance and other things you're supposed to know about that. Okay. All right, let me go back to here. Let's see, where did we have going on here? So let's get rid of that. That might be the last question actually. So let me see what they have here. Sample 4. Yeah, there's the explanations. If you guys want alternate forms, I didn't follow this exactly. There is variety in some of this. That's the logs to dollars. And that's the grid-ins. Remember to do the grid-ins. Let me just see. I don't remember. I don't think there's a grid-in sample, but let's see. Yeah, there's no grid-in sample. All right, guys, I'm going to end this stream. I'm going to start the next one with the Form A grid-ins and either combine that with the Form B grid-ins or do a fourth one at that point. I'm trying to make these granular, but also not one question at a time kind of thingy. So let's see where we can bring things at that point. Hopefully you guys are enjoying this and going to learn something from it. Please ask me questions. I want this to be interactive. I kind of surprised everybody with this, so I'm hoping because it's your day off and kind of I ended up being very free today, at least up until 4 o'clock. We're gonna have to see what happens after that. But I'm trying to meander stuff so we can get all this fitted and done. Again, I'm Greg from GregsTutoringNYC. Email me at GregsTutoringNYC@gmail.com. This takes a lot of work and a lot of effort. You guys know I have a big presence on the internet, helping you guys all the time. Please like, please subscribe. Your helping me will help you. It's reciprocity at its finest.